Good morning, good afternoon, good evening. I hope everybody's doing good, and I hope you enjoyed your day off yesterday. I have to be honest, I was thinking that we were going to have school because the snow, the wind seemed to have died down, and I was so confident. It was after 8 o'clock. I got my kids up, got them to make their beds. They're walking down. They're probably a little grumpy, and we're about to go out to the van, go to the babysitters. And all of a sudden, my pocket starts vibrating. Oh my goodness, that can't be the school. Are you serious? Sure enough, it was the school canceling. Now I'm the one that's grumpy because I had just gotten my kids up. But anyways, good to have a day off of school. I hope all of you are doing well. Hope you all made it to school safely today. I am going to try to walk you through what I need you to know for today. It's not very hard. The area of a kite and area of a rhombus, and show you a couple of examples. But before I do that, I want to show you where they actually come from. And so starting with the area of a rhombus, what I'd like you to do on your piece of paper there is to go ahead and draw a rhombus. Now what I like to do when I'm drawing a rhombus, I like to go ahead and draw two perpendicular lines that bisect each other, because I know that's what the diagonals do within the rhombus. And I'm going to go ahead and connect them. And then I'm going to go ahead and show the fact that the rhombus, this is the rhombus, has all sides that are congruent. Okay? So what we're going to try to do, like we've been doing, is break this figure down into smaller components and say, okay, based off what we've known in the past, how can we figure out the area of this figure, and then make it even simpler by actually deriving the formula for the area of the rhombus. And so, as you look up here, let's go ahead and label these vertices A, B, C, and D. And I'm going to focus in on the diagonals here. I'm going to say that AC is going to be diagonal 1, and that BD is going to be diagonal 2. Okay? And what I want you to see is that we've basically got 4 congruent triangles up here within the rhombus. All right? You can say either by side, 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 looking at all 3 sides, or you can even say by side, angle, side, knowing that all of these are going to be right angles there. Excuse me. So, with that being said, let's start to work this out. If I can do my area of my rhombus, I'm going to say there are 4 congruent triangles, and each of them is going to be the area of one of these triangles. So let's go ahead and take this triangle right here. Okay? Well, let's say that this is our base length. This being our base length from, let's say, point E to point C. Now that's actually half of AC. So I'm going to take half of D1. I'll do 1/2 the base, 1/2 diagonal 1. Okay, so I'm going to make a little note that this is my base of my triangle. Okay, and then my height of my triangle from E to D is actually half of B to D. And so my height of my triangle is going to be half of diagonal 2 here. Okay, so again, just making sure that we have everything down that we need for this. This is my height of my triangle. Okay, we said that if we go ahead and multiply the area of one of these triangles, the area of this triangle right here, by 4, we should be able to get the area, the full area of this rhombus here. Okay, and the area formula for a triangle is 1/2 the base, which we said was half of diagonal 1, times the height, which we said was 1/2 diagonal 2. Now all I'm going to do is I'm going to simplify all of this by doing this. I'm going to put 4 right here. 1/2 times 1/2 is 1/4, times 1/2 is 1/8. You just take the 2's and multiply them. 2 times 2 is 4, times 2 is 8, diagonal 1, diagonal 2. Okay? And then I'm going to multiply the 4 times 1/8. Now, if it helps to visually see this, I want to put 4 over 1 so that we can multiply it by 1/8. 4 over 1 times 1/8 will give us 4/8. Well, that simplifies to 1/2. And then the diagonal 1 and diagonal 2 just come down. Okay, so all I've done from this step up here down to here is just basic math. I'm just bringing things together to figure out what my formula is going to be. So again, the area formula that I want you to use for all of your rhombi, for the rhombus, is going to be 1/2 D1 D2. Use that every time. Okay, so you should definitely have that down in your paper there. Now the other formula that we want to look at is going to be the area formula for a kite. All right, so for a kite, I'm going to go ahead and draw one line segment, and then I'm going to draw another one that's perpendicularly bisected by that previous one. So something that looks like this. Okay, I'll give you a moment to go ahead and draw that out. Hopefully that looks like a kite on your screen there as you're looking at it. Okay, and again, breaking this down into parts that we could figure out the area of based off previous formulas that we've looked at, I'm going to go ahead and try to find the area of this triangle right here and double it to get the area of the whole figure, because I hope you see that this triangle here is going to be the same area as that triangle there. So again, if we double that, we'll get the area of the entire kite that we're looking for. And so again, I'm going to focus on the diagonals here. So if I look at AC, I'm going to say that that's going to be diagonal 1, and I'm going to say BD, again, is going to be diagonal 2. Okay? So the area of this triangle up here, I'm going to go ahead and do, again, we're doing 2 of these because both triangles will have the same area. The formula for the area of a triangle is 1/2 the base. Now this is diagonal 1. Okay, so I'm going to take that entire diagonal length, diagonal 1, that would be the base again of our triangle, times the height, which would be this length right here being perpendicular to the base. Now, if I'm going to go from E to B, you notice that this length here and this length here are the same. So E to B is actually half of BD. So I'm going to say half of diagonal 2. Again, that is going to be the height of your triangle. Okay? So, area of my triangle right here, this top triangle, multiplied by 2 should give me the area of the entire kite. Well, if I work this out, I'm going to put the 2 right here. 1/2 times 1/2 is 1/4. Diagonal 1, diagonal 2. Put times in there if you want to. Don't have to show it. And then from there, if I multiply the 2 times the 1/4, again, if it helps, put it over 1. Multiply 2 times 1 and 1 times 4. And I hope you see that the area formula for the kite, 2/4 becomes 1/2. And the diagonal 1 and the diagonal 2 just come straight down. Oh, well that's good. With all the formulas that we're going to have in this chapter, that is really good that those 2 formulas are the exact same. So for a rhombus and a kite, you're going to want to memorize, it's going to be 1/2 D1, D2. Now I want to pause here for a second because I say memorize, but I say that kind of cautiously, because there may be times where you forget that formula and you're going to be expected to maybe come up with the area. I mean, you've seen how I've worked these last 2 out, starting with nothing and then working my way down to the actual formula. If you forget the formula, be creative and figure it out, and that's completely fine. So we've got our 2 formulas. Now let's do some application here. Let's see. Taking a look at this first example, we have a kite, and we are given the diagonal lengths already. And so let's just summarize what we have. Doesn't matter which diagonal lengths, diagonal 1 and which one's diagonal 2, it does not. Okay, so I'll just go ahead and say that this is diagonal 1. Diagonal 1 has a length of 7 meters, and the other diagonal has a length of 6 meters. Okay, and so if we plug that into our formula, 1/2 diagonal 1, diagonal 2. We said diagonal 1 was 7, diagonal 2 was 6. You know, half of 6 is 3, and 3 times 7 is 21, so the area is going to be 21 meters squared. Okay. Now, I should have encouraged you to pause it and try to work that problem out on your own, but I thought that was a basic enough problem where it's just giving you everything you possibly need to know, that, hey, we just plug it in and simplify. So some of your problems like that will be like that on your homework tonight. Some of them won't be quite that simple. Let's look at one that's going to require a little bit of creativity, a little bit of thought to go into it. One like this one right here. I'd like you to take a moment, and I'd like you to go ahead and draw this picture out for me on your scrap piece of paper that you're taking notes on, so that you can show your sub that you've watched the video, and they can record your effort down as being in class and doing what you needed to do. So go ahead and pause. See if you can think through the process to solve for the area of this rhombus right here. You already know what the formula is. See if you can think of it. I'm going to take a moment, and then I'll begin to show you what you need to do. Okay, now, in order to figure out the area of this figure, I think it's very important. First of all, I want to make sure that you understand that that's that length, and this is this length. Now, the 12 is not the entire length of this diagonal. It's just from E to C. And so in order to figure out the other parts of the diagonals, first of all, the diagonals of a rhombus bisect each other. So this length here and this length here are the exact same. So I'm going to go ahead and say, I'm going to go ahead and record the first diagonal length as being 24 meters, 12 plus 12 right there. Now to get the other diagonal length, I'm going to go ahead and write down, first of all, again, if they bisect each other, those two are going to be congruent to each other. But what's more important is that we have a right angle. Why is that important? Well, whenever you're given two of three sides, this side here and this side here, two of three sides of a right triangle, what do you always have to do? You always have to use the Pythagorean theorem, okay? There's nothing easier that you can do. So go ahead and show that this is going to be x and that this is going to be x as well. And if you have to, redraw the triangle separate of the picture. If that helps out, 12, 15, and x. Okay, hopefully you can set it up and go ahead and solve in simplest radical form for what this is going to be. Okay, now I need to pause for 1 second because I want to make sure that I'm recording here. Usually I have the recording in the upper left-hand corner, and I don't seem to have that. Oh, we're still there. Okay, just making sure. All right, so going back to my problem. All right, we're on. Taking a look here, I have x squared plus 144 is equal to 225. And if we go ahead and solve, minus 144. Let's see here. Okay, 81. And then we square root that. So we get a length of 9. Okay, so we plug that in. We have a length of 9 here, a length of 9 here. And so diagonal 2 is going to be 18 meters. Now, I just want to connect this back to something we talked about at the beginning of this chapter, and that's this. A Pythagorean triple has three sides that are of the whole number lengths, and they satisfy the Pythagorean theorem. So if we look here, if this length here is 9, and this length here is 12, and this length here is 15, that is a 3, 4, 5 right triangle that's just been multiplied by 3 on each of the lengths. Okay, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. So, little side note there. So the area of this rhombus, if we use our formula, diagonal 1 is 24, diagonal 2 is 18, okay? And if we go ahead and do half of 24 is 12, and 18 times 12, 180 and 36, so that would be 216. I should know better than to be up here without a calculator, but double check me on that. I believe it'll be 216 square meters, and that will be your answer for that problem. 12 times 18, there we go, 216, okay? All right, so hopefully that was understandable. I've got two more problems I want you to look at. Kind of similar in nature, these next two. Okay. I'd like you to go ahead and draw this first one off to the left for me on your paper there. And make sure you label that 30-degree angle there. That's going to be important for what we're going to be looking at. Okay. All right, now, like the last rhombus, the diagonals are going to be perpendicular and they bisect each other, so I know that this is going to be 9 meters there. And what I really want you to see in this triangle is that you have a 30, 60, 90 triangle, okay? And so take a minute here. If I was to go ahead and draw the picture, I know it doesn't look quite right. It should look more like this. If that's the, oh, not that one. Let's do 30 degrees there, okay. There we go. Okay. If we have this as our picture there, how do we go from that longer leg of 9 meters to the shorter leg, which is unknown, right there? Take a minute and see if you can figure that out. In fact, take it all the way. See if you can figure out the entire area of that figure, that rhombus. And then when you're done, press play and see if you did it correctly. Okay, now, in order to go from the longer leg to the shorter leg, you can either use the formula or you can use the picture here. I can see that if I'm going to go from here to here, the difference is that there's no radical 3 over here. And that's what I need to get it to be right there. So I have to divide out that radical 3. The same thing's true over here in the formula. If I plug in my longer leg is 9, and let's make this side S. In order to get S by itself, you have to divide by radical 3. Now, we also have to rationalize that denominator by multiplying the numerator and denominator by radical 3. And so this is what our longer or our shorter leg length is going to be. 3 radical 3 and 3 radical 3. Okay? So the area of this figure is 1/2 diagonal 1. I could 9 and 9 is 18 times diagonal 2. 3 radical 3 plus 3 radical 3 is 6 radical 3. Again, 3x plus 3x is 6x. We're just adding the like terms there. The radical 3 is treated just like a variable. Half of 18 is 9, and 9 times 6 is 54. So the area of this is going to be 54 radical 3 meters squared. Okay? All right, again, using the 30, 60, 90 triangle formulas. Take a minute, pause, go ahead and draw that next rhombus for me, and see if you can figure it out. Again, it's a 45, 45, 90 triangle, so hopefully it'll be pretty easy for you. So go ahead and do that for me. Okay, so in this one, just like the last one, the diagonals bisect each other, so we've got those two being congruent. These two will be congruent as well, and they are perpendicular. And so if I see this 45-degree angle here, I'm probably going to fill in the other one just like that. And I probably should have said that over here in the fact that, you know, if we knew that this was 90 and that one's 30, I should have put 60 in right away. Okay, just to see the orientation of the triangle, to know what type of triangle I'm working with. Now, one thing that's true is this. If the angles are congruent, the sides opposite have to be congruent. So instead of marking this with 2 and this one with 1, I should have marked them all with 2. All right, so as you worked on this one, hopefully this one was pretty easy in the fact that if we plug in the diagonal lengths, since they're both the same, 80 and 80, okay? If I take half of 80, that's 40, and 40 times 80 is going to be 3,200. 40 times 80. Yep, very good. 3,200, and that'll be square inches there for that rhombus. Okay. So you've taken some notes. You've seen some type of figures that you can work through. Hopefully that's a good enough explanation of what I expect for your homework tonight. You can go and begin your homework, and I will see you guys tomorrow. Be safe. Good night.